Hello everyone. In today's class, we will discuss about how to find the second largest element in an array. Fine. So to find here, if you consider this example, we have elements 12, 35, 1, 10, 34, 1. So and here the largest element is 35 and the second largest element is 34. Okay. So let's start know how to solve this. So the first approach, that is a brute force approach, is by using a sorting technique. Okay. Once we sort this array, the elements will be arranged like this: 1, 1, 10, 12, 34, 35. Correct. So So 0, 1, 2, 3, 4, 5. Fine. So if you see, this last element is our largest element. Correct. If you want to find the second largest element, we can ignore this and we can start iterating from here. We can ignore from second, no, second last. We can iterate one by one. Okay. Wherever if it is not matching with the largest element, we can return that we can consider that as a second largest element. Fine. So let's write this logic. So the same example I have considered: 12, 35, 1, 10, 34, and 1. So first is sort the array. So array start sort. Okay. Once sorted, so int largest equals to, so array dot length minus 1. Right. So here it just store the length in one variable n. Here just instead of here dot length, just use the n minus 1. That's the length. So this is the largest element. Now start iterating int I equals to, I know I started from n minus 2. N minus 2 means here this one from 34. Correct. So and I greater than or equals to 0. Okay. Till this 0. This 0 means first element. Correct. And I minus minus. I'm decrementing I value. If a of I is greater than, so here just consider one more variable int. So say the second largest, yes, largest equals to, initially just consider as minus 1. So here I'm assuming all elements are positive elements. So I'm just initially I am taking the second largest variable with minus 1. If we have some negative values, then just take integer dot min value. Okay. So if a of I is greater than the second largest, and we have also considered one more, that element should not be equals to the largest, right? Should not be equals to the last that is the largest element. Then assign second largest is equals to a of I. Right? So just print the second largest. Okay. This is the brute force approach. Just run this program, you'll get 34. Okay. Here the time complexity of this approach is, since we are sorting here, so sorting will take order of n log n, and again we are iterating elements, it will take order of n. So this approach will take the time complexity as order of n log n, okay, plus order of n. This is the time complexity, and space complexity is order of 1. We are not using an extra space. Okay. Let's move to the next better approach. Okay. This is not a good approach because it's taking a more time. Correct. So now the better approach is by using two for loops. Okay. Let's see how we can use that. So this is 2, 3, 4, 5. Correct. So if we have to use first for loop to find the largest element. In second for loop, we can iterate the elements to find a second largest. Okay, let's understand it. First, just declare one variable largest equals to -1 initially. So let's write a for loop for I equals to 0, I less than n, I plus plus. If fi greater than largest, then we can assign largest equals to fi. Okay, this is to find a largest element. Okay, this we already discussed. No, this is to find a largest element in array. So, and the link will be provided in the description. Okay, the how to find a largest element. Okay, so here we will get a largest element as 35. Largest equals to 35. We know largest now. Now just write one more for loop now. For here, just consider second largest, one more variable. Let's say -1. And I equals to 0, I less than n, I plus plus. Okay. Here, if fi greater than second largest, and one more condition we have to write, that is fi should not be equals to largest element. Okay. If this condition is true, we can write second largest is fi. Close the explanation, close the for loop. So we can print the second largest element. Okay. So this is using two for loops, right? Here the time complexity is this will take order of n. Again, this will take order of n. So this is order of 2n, order of n plus order of n. Correct? So this is using two for loops. Just write the code for this as well. So we're not using array start start now. This is using two for loops. Let's declare largest equals to -1 and declare second largest also -1. Okay. This loop is used to find the largest element. So if fi greater than largest, okay, then just print largest equals to fi. This we already discussed in earlier program also. Here, so we have to find a length, right? The n equals to that length. Yeah, this will give the first largest, that is the largest element. Now write one more for loop to find the second largest. I equals to 0, I less than n, I plus plus. If fi greater than second largest, right? Second largest, and fi not equals to the already the largest whatever we calculate in the first for loop. Okay. Now assign second largest equals to fi. Now print the second largest. We are 34. Correct. This is using two for loops. Okay. This is a better approach when considered sorting technique. Got it. Now we can also optimize it. We can achieve it within single for loop. Okay. That we will discuss how to do. Okay. Now let's discuss the approach. There is a optimal approach. Within a single for loop, okay, instead of using two for loops, within single for loop, how to find a second largest element. That will take just order of n time complexity. Okay. So let me explain that logic now. Okay. So here, right, we will take a two variables, that is, we will take two variables, that is first largest with the -1. We'll take one more, that is second largest, say -1. Okay. First, we will see 12. Okay. So let's write a logic. I'll explain. We will do the dry run for I equals to 0, I less than n, I plus plus, if see that my element a of I is greater than first largest. If my element is greater than first largest, then what I'm doing is I'm assigning my second largest equals to first largest. Then first largest equals to a of I. We have to write one more else if condition. If a of I greater than second largest and a of I not equals to the first largest. Here update the second largest here. Second largest equals to a of I. Close the exit, close the for loop. Okay. Let's dry run this. Yeah. So initially first largest is -1, second largest is -1, right? I equals to 0, and here 0 less than n means 1, 2, 3, 4, 5, 6. 6 condition true. Enter. A of I means a of 0, that is 12. Okay, this is the first step. 12 greater than first largest is how much? -1. Condition is true. True means it will enter. See, if some element is greater than the first largest, then this first largest becomes a second largest, and this a of I becomes a first largest. Correct? That is the logic. Fine. So if you found some element in the array is greater than first largest, there is some element is there which is already greater than first largest, then first largest become a second largest, and this a of I is the first largest. That is what we are doing here. Correct? So here 12 greater than first largest initial minus 1, condition true. Then so I'm assigning second largest equals to first largest. Okay. So what is the first largest here? -1. Fine. And the first largest is how much now? In this case, 12. That is a of I. Correct. Now come to if O, right? So I plus plus. Then I becomes how much? 1. 1 less than 6. Condition true. Enter. A of I. A of I means that is the second step. A of 1. A of 1 means 35. 35 greater than first largest. What is how much first largest in previous step? 12. Condition is true. If condition is true, it will enter into the if condition. So it will update a second largest. Second largest equals to first largest. That is how much? 12. Correct? And first largest how much? A of I. A of I is 35. Correct? Yes. Now go to I plus plus. I becomes how much now? 2. 2 less than 6. Condition true. A of I. A of I means A of 2. That is 1. Okay, this is the third iteration. 1 greater than first largest. What is the previous first largest? 35. Condition is false. False means it will go to else if. So in else if, a of I means how much here? 1. Correct? 1 greater than second largest is how much? 12. Correct? Condition is false. So it will not update anything. Go to I plus plus. I becomes 3. 3 less than 6. Condition true. A of I, A of 3 how much? 10. Correct? So next, fourth iteration. Third iteration, nothing updated. Fourth iteration, 10 greater than first largest, still how much? 35. So condition is, here condition is false. Correct? It will go to else if. Here A of I how much? 10. Greater than second largest, still how much? 12. Condition is false. Not update anything. Go to I plus plus. I becomes how much now? 4 less than 6. Condition true. A of I, A of 4, how much? 34. Okay, let's write here. Fifth step. Fifth step is A of 4. A of 4 means 34. 34 greater than first largest. How much first largest? Still we have 35. Here condition is false. It will go to else if. Here the important point is here, if A of 4, that is how much? 34 greater than second largest is 12, right? Yes, here condition is true. And A of I means 34 is not equals to first largest 35. Yes, true and true, true. So first largest will not update anything. So second largest, still first largest is how much here? 35. Second largest is 34. A of I updated, correct? I plus plus. Now sixth step. Now I becomes how much? 5. 5 less than 6. Condition true. So A of I means 1 greater than. Okay. So first largest how much? How much? 35. Okay. Here this is 1 greater than 35. Condition is false. It will come here. A of I 35 greater than. So if condition false, right? Even it will not go to. Yeah, it will go to else if. Here A of I means how much? A of I 1 greater than second largest how much? 34. Condition is false. This and the first condition itself false. No need to check second condition, right? So it will nothing update. So the final first largest is 35. Second largest is 34. This is how we need to solve this problem in single for loop. Okay, this will take just order of n time complexity with single for loop, and we are not using any extra space, so it will take order of 1 space complexity. Let's write the logic. So let's take int first largest equals to -1, second largest equals to -1. Let's find the length of that array. A dot length. Write a for loop for I equals to 0, I less than till size, I plus plus. Write the logic. If any element is greater than first largest, right? Then my first largest becomes the second largest. Second largest equals to first largest, and of course my first largest is A of I. This is a first if condition. Else if A of I greater than second largest, I would write one more under condition. It should not be equals to first largest, right? Not equals to largest. Then update the second largest equals to the second largest. Just run the prompt and we'll get a 34. So this is the optimal solution to find a second largest element in array, which will take order of n time complexity. Okay. Yeah. Thanks for watching this video.